All right, let's take a look at the second set of challenges. This one says write an expression that computes the average of variable exam 1 and 2, both already have assigned values. So in the previous quiz on scientific notation, we took two numbers, I call them age, we added them together divided by the amount of variables. And so in this instance, it'll be very similar. We're going to take exam 1, add the score for exam 2, and then divide it by the number of variables that we have. And so that's how we calculate averages. Average of your grades can be calculated by adding all the grades and then divide by the number of grades. Or the average of your batting score, you take however many times you batted and divide it by the number of the bat. So we'll go ahead and put that together. And again, we are adding things for averages and then divide them by the amount of variables being added. All right, here's the next one. The dimensions of a room have been read into variables width and length. The dimensions of room have been read into two other variables, width and length. Write a single expression whose value is the total area of two rooms. So we're asking to calculate, perhaps we're buying flooring for a room. One has such length and width and the other one another. Well, how we would do that? Well, we have to first calculate the expression for width and length of the first room. All right, and then we simply add the width and the length of the second one. So what these exercises help us to do is to see that algorithms can be created to represent real events and real situations. And in this instance, we're simply taking length and width of one room and adding it to another. So now we go to the store and we say, hey, could we have a total flooring of this many square feet? Because as you can see, we're multiplying two lengths. Because of that, they become a square in values. All right, let's move to the next one. In mathematics, the nth harmonic number is defined to be 1, then half, third, fourth, and so forth. So the first harmonic number is 1, the second is 1/5, and so forth. Write an expression whose value is the 8th harmonic number. Now, this one might seem a little bit more complicated, but all we have to do is simply recopy what's above here 8 times. And if we do this in writing, we have 1, then add 1 divided by 2, divided by 3, by 4, and so forth. So words like harmonic and mathematics are really here to distract us. And that's what a good puzzle does. It gets your attention on one element while the actual solution is fairly straightforward. All right, and so we are calculating the harmonics here correctly. So let's move to the next step. Now, in this one, we are going to read, okay, the nth harmonic number is defined by what we just read. So the first harmonic number is 1, the second is so forth. Assume that n is the integer variable whose value is the positive integer. Assume also that hn is a variable whose value is nth harmonic number. Write an expression whose value is n plus 1, the harmonic number. So what we will do here? Well, notice that the harmonic number, so h times n, has to be added to 1 divided by, and here's where we're going to do a trick and write simply n plus 1. So if the harmonic is 0, it's going to be 1 divided by 0 plus 1 divided by 1. So it's 1. It's the first number. The second harmonic, if it's number 2, then we have the first harmonic, which was 1 times 1, plus 1 divided by, then it's 2 plus 1, then it's 3 plus 1, and so forth. So this is a shortcut. This is something that allows us to automate the calculation of the harmonics. Now, I don't expect that you would know that off the top of your head. But if you spend 5 minutes writing this out and trying things out, then that's the goal. You basically give it a try to figure out what this n+1 all means. And it simply allows us to calculate multiple iterations of a repeating pattern. And that's the key. Thank you.